So in the second part for this lecture on logical operations, we will be looking at bitwise logical operations, and we're going to start with the AND operation. So the AND is a logical AND operation, and it will gonna do a bit-by-bit AND operation with the values of the two source registers, in this example T5 and T6, and write the result into the destination register. In this example, it is T4. So let's start with an example where I have this value is expressed in binary in T5, and I have this value expressed in binary in T6. And to better understand what the logical operations do, let's divide these values into we have 5 different zones according to the binary value in each one of the registers. So the AND operation, when I do a logical AND, the result is 1 if and only if both inputs are equal 1. So the only region that will result into a 1 for an AND operation here will be the region C. All the other regions will result into a 0 because at least one of the inputs is a 0. The next operation that I'm going to look at is the OR operation. For an OR operation, the result is 1 if either of the inputs is 1. So in this case, regions B, C, and D will result into a 1. And regions A and E will result into a 0. There is a NOR operation that is the OR that is then complemented. So in this case, we're going to result in a 1 if both inputs are 0, and we're going to result in a 0 otherwise. So in this case, the regions A and E will be equal 1, and the regions B, C, and D will be equal 0. There is an XOR operation. The XOR operation is the exclusive OR, and the result is 1 if the two inputs are different. So in this case, we'll end up with a 0 in regions A, C, and E, and it will 1 in regions B and D. We can use the NOR operation to do a negation operation. So if I use the same register as for the two sources in the NOR operation, the result of the operation will be the complement of the input. So there is no instruction for logical negation in RISC-V because you can use the NOR operation for negation. We can also have bitwise logical operations with immediate operands. For example, I can do an AND-I, and I can specify an operand with 12 bits. So if I do an AND-I with 12 bits, this is what I would have. I have a source register S3, and I have a constant, in this case 0, F0. The constant is to be sign extended to produce the 32 bits. So in this case, what will going to happen is that the bits that are in the positions where this constant has a 1 will be passed to the output, and all other bits will be equal 0. So the output here will be that the only region where I copy the values of the source register S3 into the destination register at 7 is that region that is marked in the slide. That is where the constant that I provided to the instruction is has 1s. I could have also an AND-I where I have the most significant bit of the 12 bits equal 1, and it should be sign extended as shown in the slides. And in this case, the lower 4 bits are masked into 0 or are shown as 0, and all the other bits are copied. The 12-bit constant is to be sign extended in RISC-V. However, in the simulator that we use in the lab, this results in an error. The simulator has a problem when handling a 12-bit immediate that's expressed in hexadecimal. It will produce an error when you do that. There are ways around it. So here I have, I can do an LI where I load the constant into register T0, and then I do an AND with the value of that register. So in this case, I loaded that constant into T0 and I did the end. I have masked that region, but there is no sign extension here. I can do the sign extension myself if I want by using a few other instructions. So the hexadecimal in this case is interpreted as an unsigned integer. So this is what I had for the bitwise logic operation in this lecture, and I hope you enjoyed it.